Hello, Matt Davis here with some homework quiz help. This one is from section 5.5. A December 2009 article by the FINRA Investor Education Foundation reported that 54.7% of Americans said that in the last year they had always paid off their credit cards in full. Suppose that we randomly sampled 34 Americans at that time and let X equal the number that had always paid off their credit cards in full during the past year. Calculate the probability that exactly 18 of them had paid off their credit cards in full during the past year and approximate your answer using 4 decimal places. All right, as we normally do, we'll make a change in the interest of giving help instead of answers. So instead of 18 of them, we're going to do 19 of them. So very similar to what was asked, just a minor change here. The next thing we need to notice is our situation. We're looking at 34 Americans in our sample, and then we're counting or letting X equal the number of them that had done something. So we have 34 tries, and we're counting the number of successes in those 34 tries. That means that this is an NPQ situation, where N comes from our sample size of 34. P would be the probability of a success in any one try. That would be that the person we selected had paid off their credit card in the last year. According to the setup, 54.7% of Americans have done that. So P would be that percentage, but when you're doing NPQ problems and P comes to you as a percentage, you need to make sure that you convert it to decimal form before you start doing your work. So then you go to Q, which is 1 minus that, and we get 0.453. If you forgot to convert to a percentage form and you did 1 minus 54.7, you're going to get a negative for Q, which doesn't make sense because probabilities have to be between 0 and 1. So always make sure you start off by taking that decimal place, moving it 2 to the left, and getting rid of your percent symbol to convert to decimal form probability for your NPQ. After that, it's a binomial probability situation. So if you want the probability that X equals 19, you need to use the binomial probability formula, which is N choose X, so 34 choose 19, P to the number of successes, so 0.547 raised to the 19, and Q raised to the number of failures, so 0.453 raised to the leftovers, which would be 34 minus 19. So subtract that 19 from the 34, and we get 15. So there we go, and now we just need to enter that into the calculator, so let's switch over there. 34 choose 19, so you type the 34 first, and then go hunt for the choose, which is in the math menu, probability submenu, and then NCR. So 34 choose, we want 34 choose 19, times the probability of success raised to the number of successes. Notice I don't put parentheses around my value of P here. I don't need to because it's just a single number. Parentheses around P and Q are essential when it's fractions, but not necessary when it's a decimal. And then times 0.453 raised to the number of failures, which is 15. We press enter. We want this to 4 decimal places, so 0.1354, but the 4 is followed by a 5. So we'll round the 4 up and make it 0.1355. So switching back over, we end up with 0.1355, and that's our final answer there. So keys to getting this one right. Number one, you have to recognize it's an NPQ problem. There's basically no hope of getting to this answer unless you recognize it's NPQ and using the binomial probability formula. The other key is making sure that when P is given as a percentage, you convert that to a decimal before you do your 1 minus. And then just being careful with the typing and the exponents. One place to watch out for is to always make sure that these two exponents on P and Q add up to whatever your N was. That's a mistake that happens somewhere in there. So that's a little check you can do at the last minute. Make sure exponents on P and Q add up to the N. All right, I hope that helps you get unstuck on this one and that you found where things were going wrong, and good luck to you as you head back to your quiz.